Welcome. In this video I'm going to show you how you can perform a one-sample trinomial test using R and my stikpetR library. I'm using Jupyter Notebook, but the R code should also work in, for example, RStudio. This test can be used as an alternative for a one-sample Wilcoxon signed rank test or a one-sample sign test. The difference with the sign test is that this does not exclude the values that are tied with the hypothesized median, and in general it's a test that can be used to test for a specific median. To show you how this can be done, I'll load in some example data from student statistics. It has a lot of data in there, well, not that much, but I only actually need one field, and I'm going to be using the teach motivate field for that. So I'll select that field separately as an ordinal field, and to give you a quick impression, the table function can show you the count, so only 7 students agreed with whether or not they felt that the teacher motivated them. It might be good to have those in a separate vector, so in the proper order. So I'll use coding, I call it coding, and then we can use that later on. Now, my own library is unfortunately not available on Chrome, so you need to have DevTools installed, and then you can use install from my GitHub. Once you've installed it once, you can always load it by using library. And the function of interest is actually TS, short for test, trinomial, and then OS, short for one sample. I have a similar function for Python, so I'll need to change this panda series to just the data. That's the required input parameter, of course. If it's non-numerical, then the levels, which are those codings we set earlier. And you can set the hypothesized median. If you don't specify it, the mid-range will be used, which is the maximum plus the minimum divided by 2. So in this example, that should give me the neutral option, so I'm not going to specify it. I'll simply type in the name of the function, select the data, and in my case the coding that I've used, and it returns a few different values. The mu, the hypothesized median used, the number of positive scores, so that are above the hypothesized median, the number that was below it, and the number of tied scores with the hypothesized median. So 12 scores should be 3, 13 should be above it, and 29 should be below it. That gives a p-value of 0.016, and usually we would say if this p-value is below 0.05, that's the usual threshold, we would have a significant result. So in the population, most likely the median will most likely not be 3. It also shows the name of the test, and I think that's about it. I hope this video was helpful, and thank you for watching.